Could there really be a giant planet lurking beyond Neptune, so far from the Sun that it's practically invisible? A world with enough mass to twist the orbits of entire regions of space, but too cold and dark to be seen with conventional telescopes? Recent discoveries are breathing new life into the hunt for Planet 9, a mysterious celestial body that might be the last major piece of our solar system's puzzle. The search for a ninth planet in our solar system didn't start with Pluto. It actually predates it. As far back as the 19th century, astronomers like Percival Lowell suspected there might be a hidden world influencing the orbits of Uranus and Neptune. They called it Planet X. When Pluto was discovered in 1930, it was briefly considered the missing piece of that puzzle. But that didn't last. In 2006, the International Astronomical Union, IAU, reclassified Pluto as a dwarf planet because it didn't meet all the criteria. Specifically, it failed to clear its orbit of other debris. Still, scientists couldn't shake the feeling that something big was out there. In recent years, astronomers found a new puzzle. The orbits of several distant objects in the Kuiper Belt, those icy leftovers from the early solar system, appeared oddly aligned. This wasn't supposed to happen. These bodies should have been scattered randomly, yet many followed paths tilted at similar angles. Could a massive, unseen planet be shepherding them into formation? In 2016, Caltech astronomers Konstantin Batygin and Mike Brown proposed the existence of Planet 9. Their models suggested a Neptune-sized world, 5 to 10 times the mass of Earth, orbiting between 400 and 800 AU from the Sun. That's 10 to 20 times farther than Pluto. Their theory explained not only the alignment of Kuiper Belt objects, but also strange behaviors in the orbits of some high inclination, comets, and even the tilt of the entire solar system's orbital plane. Now, a new study may have found our first visual clue. A team from the National Tsinghua University in Taiwan reanalyzed data from 2 full-sky infrared surveys: NASA's IRAS satellite, 1983, and Japan's AKARI satellite, 2006-2011. These satellites scanned the sky in infrared light, ideal for detecting cold, distant objects. By comparing these surveys 23 years apart, the researchers searched for a subtle clue: a tiny, almost imperceptible shift in an object's position, suggesting a planetary orbit. Out of 13 promising candidate objects, one stood out. It appeared in the 1983 IRAS data, then vanished from the same spot in the AKARI data. That movement could indicate orbital behavior consistent with a large, distant planet. If confirmed, this object could be orbiting between 500 and 700 AU from the Sun, and could take 10,000 to 20,000 years to complete one full revolution. If real, it could finally be the long-sought Planet 9. What would it be like? Incredibly cold, with temperatures between -223 degrees Celsius and -218 degrees Celsius. Its atmosphere would likely be thick with gas and ice, potentially dominated by frozen methane, ammonia, and nitrogen. Its surface might be completely cloaked in darkness, illuminated only by the faintest starlight and surrounded by a halo of frozen debris. Estimates suggest it may be between 7 to 17 Earth masses, similar in size to Neptune but much colder and less reflective. That low reflectivity is precisely what makes it so hard to detect with optical telescopes. Even the largest ground-based instruments may miss it unless they know exactly where to look and in which wavelength. It may also possess a slow rotation, long seasons, and even rings or a few moons, though at such a distance, these would be incredibly faint. Its composition, structure, and potential magnetic field remain purely speculative. But if it's similar to Neptune, it could offer insights into ice giants both within and beyond our solar system. Unlike Pluto, which failed to clear its orbit, this hypothetical planet might fulfill that requirement, aligning and influencing smaller bodies through its gravity. It may be the reason for the unusual clustering of trans-Neptunian objects, acting as a cosmic shepherd at the edge of our system, maintaining gravitational control across vast distances. But even with this compelling infrared clue, the road to confirmation is steep. Astronomers need multiple sightings over time to trace a real orbit. Only then can they rule out other explanations, like asteroids, background galaxies, or even transient sensor noise. This is where the Vera C. Rubin Observatory in Chile comes in. With its massive 3.2 gigapixel camera and sweeping survey capabilities, it's expected to catalog over 20 billion celestial objects. Its deep, wide-field scans may finally catch Planet 9 in motion. Meanwhile, astronomers continue to comb through archival data and conduct simulations, narrowing down where to look next. Even eliminating possible zones is a crucial step, helping future observations become more focused and efficient. Whether this current candidate pans out or not, the momentum of the search is building. If Planet 9 truly exists, it would be the most significant discovery in planetary astronomy in generations. It would reshape how we understand the architecture of our solar system. Such a planet would challenge current theories of solar system formation. Did it form out there, far beyond Neptune, in a slow and cold corner of the protoplanetary disk? Or did it migrate outward? Or worse, was it captured, an interstellar orphan adopted by the Sun billions of years ago? Its discovery could also lead us to reconsider what we classify as a planet and highlight the limits of our observational reach. The mere fact that a planet of that size could remain undetected for so long raises questions about how much more is still out there in the vast darkness. Additionally, Planet 9 might help explain other celestial phenomena, like the peculiar orbits of long-period comets or the strange tilts in the orbits of distant minor planets. It could even offer insight into the early dynamical chaos that shaped the young solar system. The implications go beyond our own system. If we can miss such a massive planet right here at home, it raises profound questions about what we might be overlooking around distant stars. Planet 9 could become a template in the search for similar hidden worlds in exoplanetary systems, particularly those on the edges of their solar neighborhoods. Planet 9 is more than a mystery. It's a reminder that even in our own backyard, the universe still holds secrets waiting to be uncovered. Could a frozen giant really be hiding in plain sight? Let us know what you think in the comments below. And don't forget to like, subscribe, and hit that notification bell for more journeys through space, science, and beyond. Until next time, keep your eyes on the stars.